Hello, I'm Victor Gramm, and this is my presentation entitled 3D Modeling the World Around You Using 3D Scanning Photogrammetry to Create Models. Who am I? My name is Victor Gramm, like I said. I'm an 18-year professional IT person. I'm also an audio engineer and a musician. I'm a newly minted 3D printer enthusiast, not an expert yet, but I am working my way in that direction. Also a family man, so let's mind our language, yeah? All right, so some of my goals with 3D printing, I'd like to connect with other 3D printer enthusiasts. So if you are at all interested in forming a user group meetup outside the OKC OSH user group, let's talk. But OKC OSH is an awesome group, so let's continue to do that as well. Another goal I have is to learn everything I can about 3D printing and related technologies like 3D scanning, photogrammetry, and 3D modeling. I'd like to figure out ways in which I can apply that knowledge to improve the lives of everyone I know. And I'd like to find or create work in the industry in Oklahoma and share everything along the way. We'll be talking about 3D scanning, photogrammetry, 3D modeling, some hardware, software solutions, hardware and software solutions I've had experience with. Again, the 3D printing group, and some OKC metro area and online resources you can use to learn more. After the discussion, let's have some conversation. I'll show you the Xbox 360 Kinect. We'll also take a look at the structure sensor if you want to get scanned on that thing, and let's talk some 3D printers. So to begin, what is 3D scanning? Wikipedia tells us that 3D scanning is the process of analyzing real-world objects or environments to collect data on its shape and possibly its appearance. For our purposes today, however, 3D scanning is the process of capturing digital information about the shape of an object with equipment that uses lasers or light to measure the distance between the scanner and the object. It's a mouthful. So there's several different types of 3D scanning. I'm going to try not to go too deep in the weeds here, but you've got your Contax 3D scanners that are typically used in manufacturing and use these coordinate measuring machines. The problem with these is that they're in contact with the item or the object that they're trying to measure, so it's a potentially destructive means of measuring and attaining that data. There's also non-contact active 3D scanners. I think this is typically what we think of when we think of 3D scanners. They use radiation or light and detect the amount of radiation passing through an object or the reflection of light off the object to attain the data. These are things like CT scanners and MRI scanners. They utilize different methodologies to acquire that data. There's the time of flight method, triangulating, conoscopic holography, and there's handheld laser methodologies. There's structured and modulated light methods, and again, the CT and MRI methods that I mentioned earlier. Non-contact passive are actually the type of 3D scanners that we most frequently encounter as regular consumers. These are stereoscopic, photometric, silhouette techniques. They often use the visible and infrared light to attain all the data points. Photogrammetry has been around pretty much since the beginning of photography. It also employs mathematics that have been around for ages. So this is a great system. Again, Wikipedia tells us that photogrammetry is the art and science of making measurements from photographs, especially for recovering the exact positions of surface points. And so there's a few different industries that this is more applicable towards, such as topography, architecture, engineering, manufacturing, quality control, police investigation, geology, and the big one is cultural heritage. That's kind of one of the big drivers for photogrammetry, in that they are going around and preserving a lot of history that we're losing to wars and environmental concerns. So photogrammetry has proven to be a very valuable technology for preserving our way of life, the human way of life. It also involves many different methods and borrows from a wide variety of disciplines and sciences. All of those sciences are pretty expansive in and of themselves. So for photogrammetry to combine all of these various disciplines and sciences is pretty impressive. At least I'm impressed. There's several different major components of the data that photogrammetry is trying to kind of acquire whenever you're using this method. The coordinates that define the image in space, the image coordinates defined on the film or the sensor, the exterior orientation that defines the camera's location in space, the inner orientation that defines the geometric patterns of the imaging process. Some of this is like kind of where the special sauce of proprietary systems kind of live. Also, the additional observations component is another aspect of the special sauce that somebody might put into their algorithms and programming behind their software. And as complex as photogrammetry might seem, it's probably one of the most accessible and detailed modalities for acquiring 3D data for 3D modeling. That kind of blew my mind, but that was something I learned. 3D modeling, I think we all kind of have a loose idea of what that is. We're just trying to represent three-dimensional objects in a digital realm. There's a lot of different software packages that do this. I have tried my hand at it. I'm not so good, but I'm getting better. That was sort of my impetus for going around and figuring out different accessible ways of getting real-world objects into the digital space. So I was no good at one thing, and I tried to get better at another. The basic workflow behind digitizing three-dimensional objects: you identify your subject, you capture the subject's image data by the 3D scanning method or photogrammetry. Then you process the image data and render a mesh. You can clean up the mesh and prepare it for printing, and slice and print that sucker. Depending on whether you're using the 3D scanner or practicing your photogrammetry, there may be more or less steps involved. Your scanner might integrate some of those steps. So, lucky you. Here's some of the more affordable 3D scanners that are currently on the market. I brought in my Xbox 360 Kinect that I've kind of made to work by the means found on the internets. The Xbox One Kinect is a higher resolution, it's a higher resolution camera, so it's obviously more expensive. Then the structure sensor here is pretty impressive. It's $400. 3D Systems, this doesn't get the greatest reviews, and then the Einscan Pro does actually get some good reviews, but you can see it's kind of a little bit more costly than most. Open hardware solutions, you can find, I'm a big fan of Instructor Bulletin, so I'm constantly looking at their catalog of do-it-yourself projects, and this is kind of one of the resources that inspired me to kind of look for open source or reduced cost options here. Both of these are projects that I would like to eventually, maybe the OKC open source hardware community would be open to perhaps building out some of these projects. If you're interested, let me know. I'd love to get down on that. The software, we've got an assortment of softwares that are available. There's everything from commercially available, extremely expensive packages to your free and open source. If I can get any of this information to you guys, I'm happy to. Just, again, hit me up. My experience thus far has been in using the Kinect plus the K-Scan software, the Mesh Mixer, and then Cura finally to create the G-code that I send to my printer. I've also used the structure sensor workflow. I tried using some mobile apps and then just taking pictures and importing them into my Meshroom installation, but I will explain the limitations there. So here's my Xbox 360 Kinect setup at home. I had a fancy tripod, that's that towel, paper towel roll there, and then my lovely wifey volunteered to allow me to scan her. This is what I was able to capture with the K-Scan. I thought that was pretty impressive, especially considering the underlying mesh that it rendered. I then took that mesh, exported it to Mesh Mixer. This is a free software that will help you repair your meshes if there's any holes or if it's not watertight, if you need to get it more prepared as a solid object to be then printed out on a 3D printer. That's where you might go to do that. Then the structure sensor. The structure sensor is a sensor that, in this particular generation of the sensor, connects to the iPad 4, the iPad mini. It's a really groovy application. You have these different options that are kind of pre-configured to the types of things you might want to scan. Full body busts an object or the environment around you. That was the mesh that I was able to get of myself. And then I put this in Mesh Mixer, fixed a couple of holes, some spots that didn't pick up quite the way that I wanted them to, and then I exported both of them to Craftware and printed those bad boys off. I did. I'll pass them around here in a minute. But there's the picture. I just wanted to also have a graphic for the folks at home. Photogrammetry, here's kind of my go with that. So it's got promise. It's got promise. I went ahead and purchased the subscription to this Scan 3D. It's $5.99 a month. You take a bunch of shots, upload it onto the software, and see what it does. I think that there's some potential here, but it might depend solely on my photography skills, and that could be problematic. Now, this is Meshroom. And that's a weird laundry thing that you put in your dryer. It helps speed up your clothes. I don't really know the purpose of that thing, but I took pictures of it. And so I took a bunch of pictures on my Galaxy 8. I then uploaded these pictures into Meshroom. As you can see, it started to do a really great job, and then it died. And I started looking into it, and why did it die? And I don't have an NVIDIA card. That's the limitation. So Meshroom doesn't want to play past a certain point unless you have an NVIDIA card. So if you're going to go in that direction, again, it is an open source application, or at least a free application. I don't think it's open source, but it's a free application. Is it open source? Okay, fantastic. Well, there you go. But you can go ahead and play with that at to your heart's content if you just have the right graphics processors. So some of my conclusions from just kind of experimenting, reading, going to talk to various folks who are experts in the field, I've come to conclude that we're getting to a point where we have this technology available to us. Some of it's still a little bit cost prohibitive, but it's not if you use your diligence, exercise some caution, and employ some critical thought in buying the equipment and employing it to your uses. The depth of field sensors plus stereoscopic camera arrangements seem to be the most popular kind of 3D scanning devices that are available. There's a whole host of these depth of field sensors that are available. Microsoft makes some. I think, obviously they do. That's a Xbox Kinect, so there you have it. But there's other players in the game, and those are coming down in price as well. Open source projects are alive and well, but like any open source project, the big players try to quash them and make them irrelevant. So stay on top of that, team. We can keep the dream alive. Photogrammetry is also extremely accessible and probably the most accessible, rendering the most detailed results. It's just going to require a little bit of patience for you to kind of lock in that talent for getting the right image capture kind of workflow down. And then from there, you're also going to need to invest in some intensive graphics processing systems. Now, I'm not sure about distributed graphics networks that might be willing to process your images for you. I know that with some of the, in fact, I'll show you, one of the software programs, that's what it does. With the structure sensor, you take pictures on it sees it 3D application, and then once you've scanned everything, then it sends that off into the cloud to handle all the processing. You download the image back, and there's your 3D rendered object. It takes about 5 to 10 minutes. for it to render completely, but it's awesome. It's awesome what it gives you. 3D scanning and photogrammetry for the purposes of creating models to 3D print is more accessible now, like I said. So get into it. Let's team up and see what we can do with this technology. I do have this to show you. It's a brief demonstration of the Kinect, if anybody would like to. Do I have any volunteers that would like to be scanned? This young man. Step on up. Yes, sir. Yes, sir. Do you need to have Windows, or can this be run on Linux or Mac? If we're referencing the Kinect specifically, I know that there were some problems with the SDK files and the drivers and whatnot whenever Microsoft killed it with Windows 10. Kscan 3D, I want to say that Kscan 3D is cross-platform, but I'll have to get back to you. Do we have any other questions online? Okay. Come on up. What was your name? Max. Max is going to lend his countenance to our cause here. It's good to meet you, sir. I'm Victor. All right. So, if you would, take yourself a look there and try to hold perfectly still. I'm going to spin you, and we're going to try to get a full 3D capture, okay? All right. I'll take your silence as approval. There we go. Get you in the crosshairs here. All right, here is photo 1. Oh, wait a minute. Maybe I should get a new project going. Sorry, you are living with a gnome right now. Max. Boom. So now, just so you know, this gets a little tedious. But the scan that I got of my wife, that was 21 pictures. So hold tight, buddy. Sorry about the dead air, folks. Sorry, dude. Okay, I think I got some data there. Let's see what we can do with it. Let's see if I can remember how I did this. Okay, so the cool thing about this is you can go through each of these pictures and carve out all the extra data that you don't like. So that is a cool option. You can, well, I'll let you play with that. So we're going to try this alignment process. It's lying to you there. Okay. Wait a minute, what am I doing here? tell you what, I'm going to work on this. What I'll do is I'll conclude my presentation for today. Here's some resources. I'll make these available to you on the, I think I have a means for doing that on the Techlahoma channel, yeah? There we go, yeah. Yes, I can make these resources available any number of ways. So that's what I'll do. If you want to get in touch with me directly, go ahead and hit me up at victor@3dprintingstepdad.com. You can hit up my website, 3dprintingstepdad.com. It's new, but I'm going to put up a whole bunch of resources as I learn them